Okay, so this is Mr. Great Tech Review here in Mr. Great Tech Review Studio. Today we are going on tutorial number 18. And on tutorial number 18, we are going to discuss about the Arduino if statement. And I will say in bracket, I will call it a little bit a comparator circuit. And we know in our electronics, basic electronics, when we are using 741 operational amplifier, we know that operational amplifier, we use it as a comparator. We have a reference voltage, which is a fixed voltage, and they have a varying voltage. And when the varying voltage is more than the reference voltage, on the output side, it opens the open collector, the collector circuit. It opens. It makes it high. Anyway, it makes it high, and whatever thing you connected in that place, whether LED or a transistor, a buffer transistor, a current transistor, it turns it on, and via a relay it can switch on whatever device you connected in the circuit. So that is it. So in Arduino, we have the if statement is what we make Arduino to act like a comparator. But in that if statement we are going to introduce in today's tutorial, we are going to print it out in the serial monitor. We have been printing in the serial monitor, and you can also call up your file if you still have that analog read command where we read voltage from the pin number 5, pin A5. We read it and we show it in the serial monitor. And also I repeated that experiment again with a potentiometer. Remember when we did the resistors in series, we have 100 ohms, we have 470 ohms resistors. So you're gonna call up that file again in your system. If you're following up, you call it up again. We are not going to repeat most of that program. We are just going to go straight to the point and add our if statement so that we can see how to compare. An if statement is said, if this is greater than this, turn the LED on. Understand? So if the voltage is above 2 volts, turn the LED on. And if the voltage is below 12 volts, turn the LED low. So that is the if statement we are going to introduce in today's tutorial, and it works just like a comparator circuit, just like your 741 operational amplifiers. And if you have not learned about comparator, I will do me a favor by going back, and if you wait for me to handle that topic, it might take us a little bit time. Maybe, who knows, when I will teach basic or go to those basics. And but do me a favor by going back to your basic electronics, study about operational amplifiers, eventually the popular ones, or the popular operational amplifier that we normally use, and do me a favor by to rehearse and do yourself a research on comparator circuits, because it's going to help you a lot when you're hooking up your light emitting your LDL, your light dependent resistors, your thermistors, and the rest of them, because these are where you are going to compare voltages when you have a varying voltages, and you find out that at this particular point in time you want you want the thermostat, you want the relay to come on so that it can act as a thermostat. Whenever you are doing a thermostat related circuits, it's all about comparator circuits, and Arduino is you use Arduino to achieve that. You can also use 741 operational amplifiers and other operational amplifiers to achieve that too. So that is it. And they have LM35, which is a temperature sensor that can also help you to achieve that. If you hook it up in a 741, or you hook it up in Arduino Pro, in Arduino pins, it can help you to achieve that if you arrange your circuit very well. Okay, so let's go straight to the programming, and let's see to the coding aspects, and let's see what we can do. Okay, good. Now I have my monitor here, just like I told you. Today we are going on if statement, so we are going to repeat this. What we have here. Okay, let me close this one so that it's not gonna confuse us. And okay, you're out of here. You too, you're out of here. Okay, so I'm going to be very fast, and I'm not gonna edit this. I like to be leaving all my tutorials so that I can easily go back to it and If there are corrections that I will make, I will see my mistakes and I will make the corrections. I don't want to edit it, so I open another window using bare minimum, just like I told you. Let's go back again. You see examples, bare examples. You go to basic, you see bare minimum, basic, you see bare minimum, and that is how I got to this place. And I rename it, and go into file, you go to save as, bam, and you rename it. Okay, then you save. Okay, so that is it. So, and let's go and see. In this place, we are going to start our coding. We're going to start our coding, and okay, so that is it. Okay, so and I have, okay, on top of here we put our variables. Add our variables, int, sorry, I always forget that and capital letter int. You have read pin, which is what, A5, read pin, which is what, A5, so we'll copy read pin, which is what, A5. Ctrl C, Ctrl V. Read pin, which is what, A5. Then we have another integer. We have int again. We have what, our read val. Okay, our read val, let's do it this way. Let's put all the int and the float down. Our read val, this is our read val, RV, because this circuit, we are going to use that same circuit again. Sorry, we're going to use this same circuit, this same circuit we used on our potentiometer. Okay, so we are going to use this same circuit we use on our potentiometer. You are not seeing it. Sorry, you will see it now. Okay. So, okay, so you are going to use the same circuit. You can remember the circuit where you read your values from your potentiometer and you read it through the serial monitor. Not this one, not this circuit. Ignore this, ignore this circuit. We are going to use this. You can remember when we are turning our potentiometer and on our serial monitor is reading a different voltage via the what? The A5 pin. So that is it. So we are going to use this same circuit again, and we are going to use it. This is A5, this is your 5 volts, and this is your ground. Very simple circuit. So you still arrange it and you hook up your USB, and let's go ahead and see. So that is it. So this same circuit is what we are using. So sorry I didn't bring it up before. So now we go, we say Ctrl C, okay, and okay, Ctrl V. So read val. Then we have a long delay. I'm not going to, let me copy everything. Okay, Ctrl, sorry. Let me step int long D, is equals to what? Is equals to 3,000. I think that is what we use. 3,000 semicolon. So we're going to use int long D, copy, okay, so long D equals to 3,000. So that is what we are going to use, and we have okay. So, and what again do we have there? We have, okay, we have float. We have float. We copy our float. Copy. Paste. We have float. Okay. What variable do we have again? We have v2, which is floating. It's a floating voltage, and we have the read val. V2 is the voltage at the center tap, and it's a floating voltage. Okay, that is it. So we are going to come here to declare our pin mode, and our pin mode is what? Pin A5 is equals to what? Is equals to what? Input. So we are still going to copy this, and then okay, so we copy again, Ctrl C, Ctrl V, pin mode. Okay, we copy our baud rate, serial.begin, Ctrl C, Ctrl V, serial.begin. So it's almost the same thing, but just like I told you, I don't want to edit here because there are places that in this place now you see that there will be a difference. We are going to add our if statement, and we are going to add also potentiometer voltage. We are going to add characters. So you see how we add the characters when we are printing. Okay, because in the other one we didn't add character, we just simply seen the voltage reading from the pin from the A5, and then we see the voltage reading. Okay, so now let's go to, that is it. So we have set our baud rate, just like I told you. You know, the baud rate is the same baud rate you have in your serial monitors. You select the one, any baud rate you select here is the baud rate you're going to select in your serial monitors. Okay, so that is it. Now I'm coming to void loop, where you have a repetition looping system, where you have a repetition of you have the program to be running. This is where you set your program. This is where your program runs. Okay, so you have a your read val is equals to what? Analog read, and which is what? Read pin, which is what? A5. So that is it. So okay, so now your read val, which is what? RV is equals to what? Analog read. Analog read, in bracket you have what? In bracket you have what? Read pin, which is what? P5. Read pin. Read pin. Okay, bracket closes, we have what? Okay, so and V2, you know V2, this is V2 is equals to what? We declare V2. So V2 is equals to 5 over 1023 multiplied by what? Read val. So that is it. 5 over 1023, just like I told you, when the point here shows that it's what? It's not, it's a floating number, it's a decimal point. So 5 over 1023 will give you a floating number, will give you a decimal number. It's not going to give you a whole number. So if you just write 5 over 23 without putting point, the Arduino will just print 00000 for you, because it's seeing it as an integer. So remember, V2 is equals to what? It's a float. This is here, so it's float. So that's, so we are going to copy this. We're going to copy this. Okay, so let's copy all of this and paste here. Okay, Ctrl C. Okay, so that is it. And now we are going to serial print V2, which is this, to print V2. Okay, and V2 is this time is what? Rival. Okay, so now this is where we stopped, and this is what we are going to add. We are going to add a character so that the right potentiometer voltage is what? Is equals to what? Is equals to V2. So we are also going to print that. So let's print it. Let's add that one. I hope you are seeing what I'm doing here. So seeing what I'm doing here. So we're going to put a serial print. So serial print. We copy serial print. Okay, let's do it right here. Serial dot print serial dot print in bracket, sorry, in bracket potentiometer I think I'm correct. This is not turning. What is making it not to turn? Okay, potentiometer. Okay, sorry, it should be capital letter. Potentiometer voltage. It should be in capital letter too. Potentiometer voltages. And when you want to print a character, remember you put your what? You put your inverted comma, and put inverted comma, closes color. Okay, so I close the bracket, close the bracket, then I put my close semicolon. So now we are going to serial print. First of all, you print potentiometer voltage is serial print V2, now print V2. So it's going to print in line here V2, so it continues to print V2 in line. So this one is going to print across with this one printing in line. So you have to put a long delay. Okay, now let's hook up our Arduino. Let's hook up our Arduino so that we can now print. Remember, I told you if you don't hook up your Arduino while printing on the serial monitor, is not going. You are going to get an error message. We have done it before and we saw the error message. So let's check our circuit. Our circuit, everything is correct, and okay, all things being equal, ceteris paribus, I'm going to power this circuit. Okay, make sure you didn't hook up your plugs in the wrong pin so that you're not going to flash your Uno board. Okay, so I'm gonna hook it up and see. Okay. Okay, so that is it. That is by the way. Okay, now let me print. Let's download the program. Let's upload the program. Okay, it's going boom. Okay, so let's open our serial monitor and see. Error opening serial port COM3, port busy. What is happening? Okay, let's print again and see what is it. Error. Let's upload again. Okay, done uploading. Okay, so now let's adjust it and see. We have 1 point, we have 0. Okay, let's increase and see. We have 1 point. Okay, okay, okay. Okay, have what you have. Let's make it 2.5. Let's see, let's keep it in the middle. 2.5. Hope you are seeing what I'm doing. Let me create the so that you can see what I'm doing. Okay, camera 1, camera 2. Okay, so you can now see what I'm doing. Okay, so when let's reset and see. Okay, it's what, 2.2 volts. Let me increase it a little bit. I have 2.6. You have 3 volts. You have 4 volts. You have 5 volts. Okay, so that is it. So now we are going to introduce our LED and our light emitting diode. So we are going to hook up our light emitting diode and write our if statement. So okay, so that is it. Let's look at our program again. Okay, it's better now. Okay, you saw what I did? There is no space here. So what I did was to adjust this to add a space here before the inverted comma opens and the inverted comma closes. I'll have to add a space before the inverted comma. So that is it. Okay, so now let's think it's okay now. It's printing fine. Okay, so that is it. So now let's go and see how we can add our if statement here now. Okay, let's add our if statement. Okay, so before we start coding our if statements, let's do our hardware. Let's hook up our LED, our light emitting diode. So just I want you to understand what we are trying to do. What we're trying to do is that we have an LED light emitting diode in the system, whereby you use it as a warning LED signal to show when you are exceeding this voltage level, let the LED come on. And you cannot achieve that without using what? An if statement. So let us just not see the coding as coding. No, this is what we are going to achieve. We want to put an LED in the system so that maybe I don't want to exceed 2.5 volts. So immediately I started exceeding 2.5 volts, getting to 2.6, from 2.6 to 3 volts, the red LED will come on. So if I'm on below 2.5 volts, the red LED will be off. So that is what we are going to, that is the practical, that is what we are going to see in the real world, the practical aspect of it. And in Arduino, that is where we use the if statement. So before we will write the if statement to achieve that, to make something like a comparator circuit in the Arduino in the program, let's also do the practical, the physical, the hardware. Let's connect the hardware, and you have your what? You have your LED, your light emitting diode, and okay, let me hook up. Let me remove my Arduino so that it's easy for me. You have your LEDs, your light emitting diode. Okay, so you have the red one. Then I have two resistors there, and I'm going to pull out one, the 100 ohms resistor. I'm going to drop it here. Then I'm going to use the 470 ohms resistor, and here you have positive, here you have negative here. Okay, so I'm going to hook it up on the positive side of it. So now I go like this. Okay, in between the LED 25, this is the positive one, we go on LED 25. So okay, so I'm going to hook it up like this. Okay, now so the positive leg is what, 25. So I'm going to hook it up like this. Okay, so okay, you're not seeing what I'm doing. Look at what I did now. Okay, so very simple. Then I have my ground pin. I'm going to hook, this is ground, this is my ground. I'm going to hook up my ground. I look for ground here. I've used up the, I still have a ground pin. Okay, I can make a common ground for both of them. Let's make a common ground for both of them here. Let's see, make a common ground for both of them here, and I hook up to that ground, and that's let me make another ground, a common ground for this one, and I hook up to this pin. Okay, good. So I have a common ground now. Then I have this from this pin, from my plus pin of the resistor. Look at what I did. You can see it. Can you see it? Can you see it? Okay, so this is it from this resistor. You can see it now. From this resistor right here, you have this one. So I go to what? Any of the pin. I can choose pin 9 of the Arduino. So I go to pin 9, or I can choose pin 8. I go to pin 8 of the Arduino. I socket it. So very simple. Okay, so this is how you arrange your circuit, and it's very simple. Just an additional what, I added the LED light emitting diode, and I have a common ground to all of them. This is the common ground, this is the common ground, this is the common ground. The ground of LED comes to this place. The ground of what, like the potentiometer, comes to this place, and from this ground bar I loop it to the ground of Arduino, and that is it. So this is my read pin for the potentiometer, read to analog 5, A5 in, analog in A5, that is it. So, and this is what, the digital write pin of what, of the LED, goes to the resistor, from resistor goes to the positive line of what, of my light emitting diode. Okay, now so let's go and see how we can write and code. Okay, the if statement. Okay, so let's go to the program. So okay, now we are going to declare. We added new things. We added the LED, so we are going to declare it in our variables. So we put int here. So let's add it int. Okay, so what are we going to call our LED? LED equals what? Pin 9 LED. Okay, let's use red pin. Red pin is equals to what? is equals to, sorry, red pin is equals to what? Pin 8 is equals to 8. What am I doing? Red pin is equals to what? It's equals to 8. Sorry, made a mistake. Okay, so red pin is equals to 8. Okay, so we come to what? Okay, so we come to here, declare, so set up red pin, and we are going to say red pin is equals to what? Pin mode. Red pin should be what? Should be an output. Pin mode. So where are we going to put it? Okay, let's bring this one down. Okay, now what am I doing? Okay, so okay, pin mode, pin mode, pin mode, pin mode, pin mode, in bracket, red pin, red pin, pin mode, red pin, comma, is what? Is output. Output, capital letter, all caps, output, output, bracket closes, semicolon. Okay, so that is it. Okay, so that is it. And are we making any mistake? Okay, so we are good to go. Okay, so now we have declared it. We have written our pin mode, and red pin is what? It's an output. We use red pin. We have, okay, red pin is equals to 8. Red pin is equals to output. I have another pin mode, red pin input. That is this red pin, which is what? A5. And I have our serial monitors. Okay, so okay, now let's go to our void loop, so and write our if statements. So now you have to be very careful when you are writing your if statements. So you say if, okay, sorry, you say if my caps lock is on. So if okay, so it's not turning, sorry, if, okay, I'm correct now, I'm correct. Okay, so now we are on our if statement. So I will say, okay, if okay, so one thing with if statement, this is where you are going to declare your condition, your greater than and your less than, and let's see how this thing works. You just follow the instruction and see how this coding works. And you say if v2 inside the brackets, sorry, open and close bracket, and you put what? A close, you put a clore, a open clore, automatically it is going to close it for you. It is going to close. You check the open clore, and you add a close glory here because it's a condition, so you have to open and close glory. So okay, so now let's see. Okay, good, it has already closed it for you, so you have to be very careful before you add another one, because one thing with this is immediately you have put the open glory, it will automatically put the closed one for you. So inside this condition, this is where you are going to declare your condition. This is where you are going to compare. Your comparator circuit comes in place. This is what quantifies your comparator circuit. So if V2 is what we said is greater, is what is greater. Yes, if V2 is greater, we are going to first of all we'll do the greater. Is greater, which is what your right, this is greater, and okay, this is greater, this is my right hand, this is my greater, this is my left hand, this is my less than. So just know it's your greater than is your right hand, your less than is your left hand. So let's go and see. So that is it. So if what, if V2, this is V2 is greater than what, 2.5, what, turn the LED on. Okay, so turn it what, high. So we are going to declare it. This is where you declare it inside this what, inside this one, inside this bracket, not the glory, inside the bracket. It's an if condition. So when we declare it, we are not going to we are not going to put a semicolon because it's an if condition. Okay, so let's see how it goes. So V2, what is our V2? V2 is what? Is the voltage, is a float. So we don't know. It's the variable resistor. The position of the variable resistor will determine our V2. So it's a float number. Okay, so V2 is what? Is greater than what? 2.5. Is greater than what? It's greater. Where is my sign? Greater. Sorry. What am I doing? It's greater than what? It's greater than what? 2.5. It's greater than 2.5. 2.5. Okay, so I will close. Okay, it's already closed. It's greater than 2.5. What will happen if it is greater than 2.5? If it's greater than 2.5, digital right, red pin, what? High. Digital right, bracket, right, bracket, red pin, what? Comma, high, caps lock, red pin, high, close the bracket and semicolon. Okay, so that is it. So we have declared it, and that is it. So if V2 is greater than 2.5, digital right, red pin, what? High. And red pin is what? Pin number 8. This is red pin here, pin number 8, and this is where we hook up what? Our LED, our light emitting diode. This is where we hook up our light emitting diode. So if it is greater than what? If it's greater than what? 2.5. We use 2.5 as our what? As reference, as our okay, let's say, is it our reference voltage? Okay, yes, it's our reference voltage. It's our reference voltage. Use 2.5 volts as a reference voltage. Turn the LED was high. Okay, and turn the red pin high, and turn the LED high. Okay, so now the other side of it, if it is what? Below. Okay, now let's add the below. If it is what? Digital right. If V2 is what? Is below, is less than what? 2.5. It's less than 2.5. Turn it what? Low. So let's add that if condition, and let's go ahead. Okay, So before the delay, okay, so if you have already opened, you have already closed this one, so you are going to open another one. So if my caps lock is always on. So if bracket closes, bracket opens, okay, bracket closes, bracket opens, you put your chlorine, closes, chlorine opens, okay, you put your chlorine, opens automatically. Okay, let's bring it down. Chlorine closes. Okay, so that is it. So if V2 is less than what? 2.5. If V2 is what? Is less than what? 2.5. 2.5. If V2 is less than 2.5, what? Digital write. Okay. Digital write. Okay. Okay. Digital write. Red pin low. The digital write. Okay. Red pin. Digital write, red pin, comma, low. Okay. Bracket closes. Okay, so that is it. Okay, so I think we are good to go. Okay, so are we making any mistake? I think we are good to go. So let's upload and see. We open our serial monitor. We upload. Okay, let me hook up my Arduino. Okay, very good. So I open my serial monitor. Okay, let me upload first. Let's upload and see. Boom, so we are right. Okay, so let's open our serial monitor so that we can see what we are printing. You see the voltage level. Okay, potentiometer is what? Is 0. Is 0. So it's not gonna turn what? It's not gonna turn high. Okay, let me come down. Let me shrink it a little bit. Okay, this is the highest we can go. Okay, let's keep it here so that we can see our conditions. Okay, so now we said in if condition, say if V2 is what? It's greater than 2.5, digital write red pin was high. Okay, and if V2 is less than 2.5, digital write low. So now our voltage of source is 0 volts, so it's less than 2.5. So let's, okay, this is not making contact. It's not making contact. Okay, it has started making contact. Okay, so now the voltage is what? It's 5. It's 5 volts. So let's bring it down to, just be watching the serial monitor. My hand is blocking. How will I do it so that my hand will not? I want to the situation whereby you see what I'm doing. Okay, let me turn it this way. Okay, in such a way. Okay, very good. So let me clear it again. We have what? we have what? 4 point what? 4 point what? Okay, we have 5 volts, which is what is greater, so it's going to turn high. So when we go below 2.5, it's going to turn low. So let's start moving. Now 4.8 watt, 4.61, 4.33. Let's be going. You have 0. You have, okay, you have 3 points. Let's go again. You have 2.6, and what we declared is what? If it is what? 2.5, 2.56 is below, so 2.4 is off. 2.4 is off. So you can see 2.4 what is off. 2.5, if it's what? It's above 2.5, so this is what? 2.6, 2.63. It will come on. Can you see it? Okay, when it's below, it goes off. 2.7, 2.17, 2.12. If it's above, it comes on. Okay, so that is it. So now this is actually what we, and okay, so now I just want us to understand what is going on here. Let's not just see it as something that we just you know, put in just an experiment to just see how we can turn an LED on and off with if conditions, with your condition statement inside your Arduino. Let's bring it to the real world practical application, because everything we are doing now, when we start hooking up sensor, it's just like the ABCD that will help you in maybe in your secondary school. When a teacher is detecting, you can now read, you can now write. So if you don't learn the ABCD in the nursery school, or if you don't learn the basics of alphabets, the basics of English in your primary school, when you get to high institution whereby the teacher no longer writes in the board the text for you, you find it difficult to comprehend, right? So this is just the basics, so that when we start doing complex projects in Arduino, when we start hooking up sensors, when we start adding contactors and other interface to interface with Arduino, where Arduino will now become the main brain controlling every other electrical equipment, both valves, motorized valves and solenoid valves, you will not be thrown off balance. So I just want us to understand it. So let's use a very simple battery charging circuit system, whereby you have a voltage, you have a charging voltage. When the charging voltage is what? When the charging voltage is around 13 volt, 13.7, 13.5, the battery has to cut off. The battery charger has to cut off. That is it. When you have a 13.5 voltage, the battery charger has to cut off. So what is happening inside that battery charging system? Even in your car, it's everywhere. Any place you have battery charging system, your inverters, your UPS, you have, when a battery is what? 13.5, it cuts off. For 12 volts inverters and 12 volts battery charging systems, when you have 13.5 or you have 27 volts in 24 volts battery charging system, it has to cut off. That is it. And when the voltage is below what? 10 volts, it has to what? It has to come on. What is happening there? It's just a simple comparator circuit. That is just a simple what we are doing here. That is what is actually happening there. So by so doing, you are using one stone to kill two birds. You have already built a control for battery charging system. Very simple. You have built a control for battery charging system. So what are you going to do? You find a way to feed in those voltage inside the Arduino. And your output that is controlling your light emitting diode, this light emitting diode you are seeing now, is what? Is your control. It's where you can hook up your solid state relay. You can hook up your what? Your shield, your Arduino shield, your relay shield, and you start controlling your what? Your charging system, your relays and rest of them. So that is it. That is actually what is going on here. So if you don't understand the if condition, you cannot be able to compare two values. Understand? To compare two values. Now we are going to go step further. We are going to introduce, maybe use 3 LEDs, and they have, whereby you have a warning signal. Maybe you have a yellow, the red will be the maximum, and you have a green. when it's at a very at a condition, at a normal condition, it gives you green light. When it is hitting the abnormal condition, going towards abnormal condition, it gives you what? It gives you a yellow light. And when it is above abnormal condition, when it's off, when the limit is you have reached the limit, it will give you a red light. So we're going to use what? We're going to use what? 3 LEDs. Now we have you have 3 pin modes. You have 3 pin modes. You have you have to use 3 pin and have 3 pin mode, and that is it. So we are going to declare them, and the red pin we are going to use, green pin we are going to use, yellow pin. So, and we are going to declare all of them, they are what? Output. They will act as an output. Okay, so that is it. And you can also use it to compare also when the battery charging system is fully charged. You see what? You can also use it that way, and you see the light. It will show you green, it's fully charged. When it is not fully charged, it can also show you what? It can show you what is on yellow, and when the battery system is down, it is not charged at all, it will show you red. So depends on how you are going to use it in your real world application. So all of that, you're going to use your brain to figure it out. But now what we're going to do now is that we're going to create about 3 conditions where your LED has to turn up, where you have green, you have red, you have yellow, and you have what? You have red. So let's dive in and see how we can achieve that using 3 pin modes and the conditions, how we can write that one. Okay, so that is it. Let's go and see. Okay, so now we can now see how we hooked up our 3 LED here in this breadboard. I have 3 LED hooked up here. Just to expatiate more on this if command. Okay, so and the if conditions, the if command, I will use I'll write different types of conditions we have, so to be able to, so that you understand this. Before we go into the practical, I've set up my practical I've set up my, this one should go here, and this one be here, so that this one should be here. Okay, and I have to picture this. Okay, so let me get this shot. Okay, very good, nice shot. Okay, so that is it. So this is our LED, our 3 LED, to show to indicate levels of voltages, our limit, our safe level, and our no-go area, the maximum, the red zone. So I have this is the green zone, and when we open the IDE, we see the voltage level, we set this green zone, and this is the yellow zone, and it's the blinking zone. Once you get to this level, you know that you are already exceeding boundary, and this is the danger zone. These zones show no-go area. Go back, go back, go back, go back, go back. You have already exceeded the limit, so you are going to a yielding point. The elastic limit has been exceeded. Before you know it, it's going to break up. So that is the scenario here. So this is green zone, this is safe haven, and this is the green zone, this is the yellow zone, the midpoint, and this is the danger zone. So okay, and we can also use like I told you, if you are going to use a different scenario, like a battery charging scenario, where you have this at this level, you know that the battery is okay at this level. At this level, the battery is a little bit coming up, is maybe it should be at 11 point something. Let's use 12 volts battery as a point, as an example. So at this level, the battery is maybe 11.5, 12 volts. It's not all that full. At this place, you have 13.5, getting to 14 volts filled up. Then at this place, you have 10 10 volts and below 10 volts. You have 10 volts and below 10 volts that you need your battery needs to be charged. Okay, let's use another scenario. Let's use a different scenario whereby you have okay, let's use a scenario whereby you have a liquid level. You have a liquid level whereby you have your liquid level at this point in time, at this junction, this place, you have your level is okay, and this place you have, maybe you have half tank, and this place you have empty tank. So that is it. At this level is empty, you need to refill. This is warning. When you get to this level, it's warning. When you get to this level, it's empty. So that is it. So you can also add more LED. Maybe you can add a blue LED, green LED, yellow LED, and red LED. I think that with our can also add a white LED, blue LED, then green LED, yellow LED, orange LED, and red LED. Also, if you want to increase the levels to show, to differentiate at different to differentiate the different levels, so you can also do that one as an additional assignment for you. You can add that one and use it to boost your project. So I have to do more coding on that. Okay, so this is what I want us to do to add up to what we have programmed before. We used one light emitting diode. Now we have added another two, the green and red. So we play it and see how this goes, and see how it goes, okay, see how it goes, and okay, so okay, so let's go to the system and see how we can. Okay, before we go to the system, let me also write the different if conditions, and let's see. Okay, now you have if statements are known as conditional statements, and you have the types. I'm saying types of if condition. So now I can say this one, you know, this one, and this one is greater than, which is equals to greater than, then you have this, which is what, less than. Okay, so you have this, which is what, less than. Okay, now you have another one. You have equal to, which is this, which is equal to. Okay, then you have and, which is this one, normal and, which is this, which is and. So you have it as this. This is and. If you want to represent and, this my marker is already. Let me see. Okay, then you have or, which is like this, or which is like this, and is what is equals to or. So you have a bar. This is or. Okay, so that is it. And okay, So in this is how we are going. These are the things we are going to make use of. The if condition, the conditions we are going to make use of. And they have another one, not equal to, that is this one, not equal to. I'll write it here, form like this, that is equals to, not equal to, not equal, sorry, not equal. We have this like this, not equal. So we are going to make use of these conditions, all of them. We are going to make use of all of them, so that you can see at the at every we will have to introduce a various scenario whereby we will assimilate all these conditions. These are types of if conditions. Okay, so that is it, and we will go to the system, and okay, we'll go to the system so that we can make use of them. And okay, I will play this, and I will go to the system. I will play this. Okay, so I will plug this one to my system so that we can see what is inside, and with the serial monitor you can see what I code there. You can hear the sound. Okay, so you can see one LED is already on, so it's already playing what I've already downloaded in the microchip. Okay, so let's open, this is I have so many IDE opened here, so we'll take them one after the other, so that to reduce time, so that we have already spent much time on this if statement command. So I just did this one outside this video so that we can be very fast, but I will explain what I did here so that I will not be wasting time in these videos, so that your watch time will also reduce, not to have cumbersome large files. But okay, so and I will explain what I did here. Okay, so now I have 3 LED here. Okay, so let me download, and so that you can see, let me upload again so that it can actually get the right one. Okay, so now this is it, and I open my serial monitor. Okay, let's see. At 1 point what? At 1.7 volts, I have the green LED on. Okay, sorry, the serial monitor, is it showing? Okay, yeah, it's showing. So at 1.74 volts, I have the green light on. And what did I say that green light, green LED? Okay, now we have my what? I have my green LED, which is at what? At pin 6. Okay, I have it at pin 6, and pin mode green what output. So it's an output pin. I hook it up in output pin, which is pin what? Pin 6. Okay, now where is my if command for the green, for the LED green pin? Okay, so okay, I have digital write yellow pin. Okay, now let me see. Digital write green pin high. Okay, so this is it. This is where it is. Digital write green pin high. Okay, correct. Okay, if what? If V2 is what? Is less than what? If V2 is less than is less than or equals to 3.5, then I have my what? My digital write green pin what? High. So what I have here is what? Is 2.4. I say I have 2.4. So if it is what? If it is less than what? I say digital write green pin high if V2, that is V2, the voltage from the potentiometer, V2, the varying voltage from potentiometer. If V2 is what? Is less than what? Is less than or equal to, is less than equal to, is less than or equal to what? Equal to what? 3.5. And what I have here is 2.7. Let's play output again. Let's start again. I have 2.6. So it's supposed to be what? Is high. So it has not reached the what? The set point. So let's increase it and see. Let's increase. I changed my LED, I changed my potentiometer from this because this one is not all that stable, so I have to change it. So sorry for that, I didn't inform you. Okay, so I changed it to this one. This one is more stable. Okay, so now I'm going to increase it. Let me reset again. So let me increase it so that it will be above what, 3.5. So you will now see it will go off and the yellow light will come on. Okay, it's what? Okay, let's go again. 2 points. Still 2.5. Let's go to 3.06. 3.06. Wow, so 3.6 is off and the yellow light has come on. Okay, so and the yellow light has come on and it's a blinking because it's a warning. Yellow light is warning, so I program it in such a way that it's going to be warning you, blinking. And the delay is what? I put a delay, although I did a wrong programming. I didn't use variable for the delay. I just used, because that's the only delay I have here, so I can work. Okay, I can just play along with it. It's only two how will I say it? It's only 2 line of programs, so I can easily correct them. But in such a in a case where we have a lot of delay, you have to declare it. You have to use variable. So I didn't use variable for the delay. So I have delay 1 watt, or I have 1000 watt millisecond, which is what delay on and delay off is 1000 milliseconds. So that is it. So now you can see now the green light is off because what we set it can only be high. The green can only be high. Right, digital right, green pin high. If this and this, and low, this is where we put the low. Green pin low, this is low. So let's check the if statement that is binding this command. The if statement that is binding this low command. So this is it. Okay, so the low of the green is embedded here. Okay, V2 is what? Is greater than 3.5. If V2 is what? Is greater or equal to 3.5. Is greater or equal to 3.5. At that condition, this my guy here will be also low. The green pin will also be low. And when you check is what? Is greater is 3.7. So it will turn low. It's going to be low. And also, what again? What will happen? What will happen? Okay, and if what? And V2 what is less than or equals to 4.5. V2 is less than or equals to 4.5. It will also be low. So this if statement is also binding what? The green pin at the low low command. Low command is when the output pin is not generating any voltage. So at 0 command, that is it. Okay, now you can see now it's not only binding this green pin, which is what? Digital right green pin low. Okay, so now it's also binding what? It's binding another pin here. Okay, it's binding another pin here, which is what? Yellow pin, which is what? High. So at this command, it will also turn this one. It will execute two things at the same time. This command, this if statement, will also turn this one high and this one remains low. So it's executing what? 2 commands at this place. It's using one stone to kill one stone to kill 2 birds. So you see, one command is executing, is binding these 2 pins at the same time. Okay, so now let's see digital right yellow pin high. When V2 is what? Is greater than 3.5. I have 3.7. That's why it's high. And also equals to 3.5. Okay, so it's more than 3.5. It should be high. and V2 less than or equal to 4.5. So it's less than 4.5, but it's not also equal to 4.5. It's still less than 4.5, so it will still be turning, it will still turn it high. Okay, so let's move ahead. And when yellow is going to turn low, digital writes yellow low, yellow pin low, when if this is the only command binding the yellow pin, which is the yellow LED, which is on pin what? Which is on pin 7. So digital write pin 7. Okay, which is green pin, which is yellow pin, sorry. Okay, now this is the command binding it. This is the if command. So under this command, this control, you have V2 is what? Is less than 3.5. Is less than 3.5, or this is or V2 greater than what? Greater than or equal to 4.5. This one is low. So now I have 3.7. So it will also be what? It still be high at 3 point what? At 3 point what? At 3.7. He said, let's go again and see. If V2, sorry, where am I? Yellow, okay. Digital write yellow pin. If V2 is what? Is less than or equal to 3.5, it will be low. If V2 is greater than, so it is above, so it will be high. It's not less than, it's above, so it has not reached what? 4.5. So immediately I'm hitting 4.5 from here, it will turn what? It will turn off. It will go to 0. It will be low. It will turn off, go to 0, it will become low. It will turn off, go to 0, and becomes what? Low. So no command. Okay, so let's go and make it the voltage, the varying voltage. Let's make it what? More than 4.5, so that this one will deactivate, so that this LED will deactivate, and for us to activate this. Okay, so I'll go. Let me clear the output so that we can see. Okay, right. Okay, so I'm blocking. I'm still, this is 4 point what? It says 4.5. I'm still at 4.1. So let me go again. Good. I have what? 4.5. 4.57. It's more than 4.5. 4.57. So one thing with Arduino is somehow precision guided. It's just like you have precision guided missiles that hit their target with high accuracy. So Arduino is somehow precision guided. It hits its target with high accuracy. If you set 3.5, anything you have be above 3, even if it's 3.51, it's going to execute. That is Arduino for you. So Arduino is somehow it's precision guided. Its precision is very accurate. All those operational amplifiers we use in analog electronics, most of them you find that there are errors. Tolerance. The tolerance level is very high, but this one, the tolerance level is not high. It's, the level of tolerance is accurate to the point. That's what I mean. It's accurate to the point. So it's precision guided. So it hits its target with high accuracy. So we have 4.57. So we don't have 4.5. What we have here is 4.57. So it has to turn on. Even though we have 4.51, it has, this red light has to come on. This red light has to come on. Okay, let me go down a little bit. boom, I have 4.32. Yellow light has to come on. Correct. 4.32. Let me go a little bit. 4.38. The yellow light has to come on again. It has to be blinking. Okay, good. Let me go again. 4.5. 4.50. It comes on. Correct. Just like I told you, it's precision guided. As I'm hitting 4.50 on the dot, it activates and shut down the other ones. So you can see the power of Arduino. You can see how accurate Arduino is. Microcontrollers is. These switches, they turn off and on at a very high speed, and they are precision guided. So they are precision. They hit their target with high accuracy. Any target you want to hit, you hit it with high accuracy. So it's not like it's about 2.58586 this and that. If it is 2.5, it's 2.5. If it is 2.585, it is 2.585 or 2.586. So with high accuracy, that is Arduino for you. Okay, so that is it. So that is it, and you can see what we have demonstrated. Then we can now go into the programming. I will just remove everything. We'll build it together. We now go and program it together. Now you can see how we achieved, how we got to this point, and and you can also add a little, like I told you, on your own. Try as much as you can to increase the number of LEDs. So that means your program has to increase. So you increase the number of light emitting diode, and your program also has to increase. So that is it. So you make it 6 to be more precision guided, to be more accurate. You make it 6. If you have a level control, if you have a level controller and that is controlling your, maybe your crude oil, whatever you have, your oil, your fuel, your gasoline, your water, level control, you don't just have about 3 levels. No, it's not precision. You are not accurate, or that accurate. You are still guessing. But when you have about 6 to 7 levels, you can be able to say this is half, this is 1/4, this is quarter. So this is it. So that is it. So that is it. So by the time we finish the Arduino and get to Raspberry Pi, you will be able to understand this Arduino program. So there are higher boards. You have Arduino Mega and rest of them, and all the Arduino stuffs. And I'm not going to go into that. By the time we finish Arduino Uno, we have to enter into Raspberry Pi. And Raspberry Pi is more expensive than Arduino and has more capacity. Raspberry Pi is just like a computer. You hook up your monitor, hook up everything, hook up your mouse, hook up your keyboard, and you just program it like a computer. So that is it. So that is a full-blown computer in a miniaturized form. Okay, so that is by the way anyway. So let's go ahead. Let's remove everything. Let's start afresh and build the circuit and write the program so that we can move ahead. Okay, that is it. Okay, so okay, which camera is going to pick? Okay, camera 1, pick up. Okay. Okay. Good, let's go. You have your circuit diagram here, your schematic. Let's go ahead with the schematic so that you understand how this thing flows. Okay, so you have your schematic here, whereby you have your, like I told you, you have your variable resistors. This is your variable resistor. This is your potentiometer. This is your potentiometer. You hook it up to the Arduino board, 5 volts. 5 volts. This one comes to this place, and this one comes to the what? The ground. VND. This is what we use. The what? This is ground. This is 0 volts. We use P what? we use what pin? Read pin. Okay, so you have your 5 volts pin. You have your ground. This is your Arduino. Your Arduino. This is your Arduino. Okay, this is your, how many K I used? I have shown that I used 50K. 50K. Okay, so and this place goes to the what? This one goes to the what? To the pin A5 of the what? Of the Arduino. Okay, so that is it. We hook up this one, so let's see how it goes. We'll hook up this one first before the other ones. Okay, so we keep, like I told you, you have your okay, this is your center pin. You have your center pin. This is your center pin. Okay, which goes, this is your plus pin, and this is your minus, your ground. So I have so many things here, so I'm going to hook up this ground to the this ground bar here, because I have so many things that we hook up on this ground. So I'm going to, it's my Arduino, so this goes to what I have in my circuit, goes to what? 5 volts. It goes to 5 volts. Okay, here you have your 5 volts. You have your 5 volts. Okay, so then we have this one goes to what? To the read pin A5, analog pin A5. This analog pin A5. So I'm done with this. Okay, now I go with my LED, my light emitting diode. This and my light emitting diode. So I told you the longer leg is the positive. The longer leg here is the positive. The longer leg is the positive. So this is the longer leg. So this is the longer leg, is the positive. So I go with the longer leg. I have my red. So okay, so now I have my green, my yellow. Okay, so we have the green LED, have the positive, which is the longer leg. Insert it. So now I have their ground, or the ground hooked up. Okay, first of all, let's put the resistors, the fixed resistors, the 470 ohms resistors. Okay. Now you have their grounds. I'll start with this one. Hooked up to the ground, to the common bar. You have the ground of this one hooked up to the ground here. Common bar. You have the ground of this one. Hooked up to the ground here. Okay, so that is it. And you have I will use okay, so that is it, and hook them up, and I will use my steel ground. See whether I still have red and black. Okay, still have black. Okay, so still have the common ground hookup. You look for a ground either here or here. There's one ground here. There's one ground here after 13. So I hook it up to this ground here. Okay, so now red goes to what we used. I used my red pin as pin 8, so I hook it up. This is my red wire for my red LED, pin 8. I hook it up. Then my yellow goes for what? Pin 7. I hook it up. And my green goes to what? Okay, I'll remove this. I'll use this. I'll replace it with this. You understand? Let me just, for the sake of this A5. So I will use green. I use this green. I'll use this green. It goes to what? Pin 6. So that is it. My circuit is ripe now. I'm ready to go. Okay, so that is it. My circuit is ready to go. So I can now plug my USB. Good. Then I will plug it to the system. Okay. Okay, you can see the old program is inside. So the old program is inside. It's still at see. Okay. Okay, so that is it. So look, let's go and see let's go to the program, and so that we can have different scenarios, and we can code. Okay, this is our first if statement, and on this one, this is the first one we did. On this first one we did, we have we said, on this one we said, okay, you are not seeing, let me make so that you can see. So that you can see, that should be camera 2, camera 1. Okay, you can now see, and let me make it a little bit bigger. I think it's okay like this. It's okay like this, so you can see now. Okay, so that is it. So in this first, this is Mr. Grade Uno if statement. Okay, in this first one, this is the first one we did, and what we just digital write red pin high. If okay, if this is what? If V2 is what? Is greater than 2.5, red pin, digital write red pin high only. Okay, then low, if V2 is less than 2.5, digital write red pin low. Okay, we did this one, so let's upload it and see. Let's upload and see. Okay, let's open our serial monitor. Okay, so the potentiometer voltage is what? The potentiometer voltage is what? Is 4.75. So, and what we said here, we said if the potentiometer voltage, which is potentiometer voltage, which is V2, is what? Is 2.5. You should make this one is what? Is high. So it's more than 2.5, so it's always high. And if it was less than 2.5, you should make this one low. So let's bring it less than 2.5. Let's go again and bring it and make it less than 2.5. Just be watching the serial monitor. Let me just clear it. Be watching the serial monitor. I'm coming down. I'm coming down. 3, 3.6, 3.4, 3.2, 2.8, 2.6, 2.25 is off. 2.3, 2.6 is on. 2.49, not up to, it's not up to 5, it's 2.5, so it will remain 2.49. Even though it is 0.1, it's still, that is, Arduino is precision guided, that is very accurate. It's not like operational amplifiers, 741 op amps, that it's not all that precision guided. It's very accurate. Okay, so you can see now, this is the first one. Okay, now let's go and modify this program so that I can put different if statements, so that we can go ahead, just like I showed you the different conditions, if conditions, so that we can add different conditions. If this is equal to this, this should happen. If this is equal to this, this should happen. Okay, so that is it for this one. So let's bring it down. Okay, so now let's call up another one. This is okay, let me cancel this. So let's go to 1. On this one, okay, on this one we added a delay, and what do we use here? And we still, how many pin? You still have pin, red pin, only one red pin. Okay, so in this place, see the difference. In this place you have only red pin in this place. You still have only one pin, which is red pin. We didn't add the LED, so there's no, look at your what, your variables here. your variables, and your pin mode is what? It's only red pin output, red pin output, read pin input, and read pin is what? A5. That is it. And serial begin your baud rate, and that is it. That is it. Brilliant. Okay, so we changed, we added what? We added and here. We added the and what? The and command. We added the what? The and command. So that is it. So we added the and command in this place. Okay, so now let's look at what this command is all about. Let's look at what this command is all about. Just like I told you that the types of command you have the and command, and what this command is all about. Okay, so let's go and see. And they said if all things being equal, every other thing, you understand this one, so we have passed this level, so we are at this level now. So the same greater than is greater than 2.5, and look at how it is written. And I added another one. So there are two conditions here. There are two conditions, not only one condition. There are two conditions inside this if statement. There are two conditions here, and v2 is less than 3.5. Okay, you see it now. So it will not exceed 3.5. So even if it is what? You say if v2 is greater than 2.5 and v2 is less than 3.5, it should remain what? High. So this is what? Is the reference voltage 3.5. Okay, now at this place now, if v2 is less than, remember here is greater than, if v2 is less than 2.5, it's less than 2.5, or it's another what? Another command, another if command. I told you have types of what? Types of if what? Types of conditions, sorry. Types of conditions. So this is another condition. Or v2 what? Greater than 3.5, it should become low. So even if it's greater than 3.5, it will become low. Even if it's less than 2.5, it will become low. So when we hit 2.5, low. Above 3.5, low. So it's in between 2.5 and 3.5 that this thing will turn on. So it's in between 3.5, 2.5 and 3.5. So if you have 3.6 on, if you have 3.51 low. Okay, so now let's do it. This is another condition. Okay, so now you have your long delay, you have your delay long D, just like I told you, so that you can be able to see that what you are doing. Learn how to apply delay. So your vehicle must have brake. Any vehicle without brake is disaster. So your brake is your delay. Okay, so now let's go. Let's download this. Let's upload this. Then we open our serial monitor. Mind you, if your serial monitor is already open, you find it difficult to upload. And if you upload immediately and open your serial monitor immediately without applying a little delay, you will still have a problem. So now we have finished uploading, so we can now open now. It's good. Okay, now let's see. The voltage is what? 2.5, and the red LED is what? Is off, because that's what the program said. The program is if this is 2.4. If it's below 2.5, it should go off. So it's off. So it's only from 2.5. This is 2.4 now. It's only on 2.5 to what? To 3.5. It should come on. So we go. Let's check our voltage again. Okay. 2.5 is on. 2.6. When I'm hitting 3.5, it still be on. Above 3.5, it will go off again. Okay, 3.3. Let me clear again. 3.4. 3.43. 3.7 is off. 3.7, 3.49 is on. 3.5, 3.52 is off. 3.48, 3.48, 3.48, 3.49 is still what? It's still on until I hit 3.5. It will go off. Arduino is precision guided. 3.5, 3.50, 3.51 is off. Okay, so let's move ahead. Okay, let's explore other if conditions. Let's explore other conditions. Okay, now we have done this one, and the or condition. We have used and. Look at it here. Use and. We have used or condition, and two conditions here, two conditions here, two conditions here, two conditions. Total of 4 conditions. Total of 4 conditions. Look at it. The first condition, the second condition with and, the third condition with or, and the fourth condition. Okay, now let's go ahead and explore other conditions. Okay, I'll close this one. I'll close this one. Okay, I'll open this one. Okay, in this one, what is different here? What is different here in this two? Okay, okay, and 2, nothing is different. And okay, nothing is different here. It's still 4 conditions with and or, and nothing is different. I didn't change voltage value. Okay, so let's close it. Off you go. And 3, this is where I did a lot of things here. Okay, so let's open 3 and see. Okay, good. In 3, we added what? We added a delay. This is where we added a delay in the condition. We added a delay in the condition, different from what? From the delay we have here, the long D. The long D we have here. Where is my long D? 3000 milliseconds. Okay, 3000 milliseconds. We can reduce it to, okay, let's leave it at 3000. Okay, write fast. Write fast. Serial monitor, let's make it 2000. Okay, okay, so now in this place we declared our variables. Read pin is A5, read pin is A5. We declare a variable A5, read pin to the variable resistor. Okay, and here int read val, we didn't declare it, we just write read val. Int long D 2000 milliseconds. Float V2, we didn't declare V2 because it's a float number. It's floating. So many things can become V2, so it's floating. Okay, and the int read pin is equals to 8. This red pin connected via this resistor passes through this wire and goes to what? Pin 8 of their what? Of their Arduino. So that is it. Yellow pin is equals to what? 7. The yellow pin is what? The yellow LED connected to via this resistor, passes through this yellow wire and goes to what? Pin 7 of the Arduino. Okay, green pin is equals to 6. Green pin, this is the green LED connected to this 470 ohms resistor, passes through this green wire, goes to what? Pin 6. Finish. We have set up our variables. Now pin mode, just like you know, you have what? 4 pin mode, your input and your 3 outputs. Your input, and your 3 outputs. So let's start with the first pin mode. The pin mode, red pin is what? Output. Red pin, look at it, pin 8 output. That is red LED. Pin mode, yellow LED, this is yellow. Pin 7 output pin. Green pin, which is pin mode, green pin output, which is pin 6. And pin mode, read pin where the serial monitor read from is what? A. Look at it, A5. Then serial begin, your baud rate. You put your baud rate here. Okay. Void loop, looping system, where the music will play and start again and start playing, and stop and start again and start playing, autoplay. Okay, look at it here. Your piston and rings will continue to jump up and down, and your vehicle will continue to move. Immediately it stops, your vehicle stops. So it's a continuous process, up and down movement. So that is it, using different scenario. Even if you're a mechanical person, you understand what we're doing here. Okay, let's go. And he said read value. Okay, we have passed this level. I will not repeat this level again. If you didn't understand what we did here, this calculation we did here, 5 dots over 1023 dots in bracket multiplied by read value, you visit our previous tutorial where we treated this topic, how to print using the serial monitors, and how to print values. Okay, potentiometer voltage is what? How to print alphabet. You put what? Your parenthesis. Okay, so serial pin and the rest of them. Okay, so this is where we are, the if condition, the if command. Okay, the if statement. Now let's go and code. Okay, if v2. Now we are going to start with what? I started with what? I started with yellow pin. You can start with red pin. Depends on how you flow. Me, I flow with red and with yellow pin. I want to do the yellow pin first and do the red pin last, and do the green pin second. So I started with what? Yellow pin. So now I said if whichever one you start with is still the same thing. Even if you start with green pin, it's still the same thing. The conditions are still the same thing. So just set your voltage right, set your values right. You still get the same answer. You still arrive at the same junction. Okay, now so let's go and see. I will read. If V2 is what? Is greater than or equal to 3.5 and is greater than or equal to 3.5. Okay. And the V2 is what? Is less than or equal to 4.5. So this one should turn high. So this one, if this one is greater than this one, so from this to this, 3.5 to 4.5 is only when this my man will turn high. Only. Every other condition it will remain low. Okay, it will remain what? Low. Now delay. Because it's a yellow pin, just like I told you, I started with it because I have to apply a blinking program there. A blinking program, a delay program, because I want it to blink. It's my warning light. It's my warning light. I want it to blink. It's my warning light. I want it to blink. This yellow, I want it to blink. So that is why I apply a delay program there. So that is it. So now I apply a delay of 1000 watts milliseconds, which is 1 second. Okay, so this is how I did it. Digital write, normal. Digital write, delay program. Go to our Morse code. You see how to write delay program. And first, that should be our first program. See how to add delay. Okay, now write high, yellow pin high. On this condition, this yellow pin should turn high. So I delay it when it's high. I delay it. Digital write off. I delay it again. I write off again. It goes off and comes. It goes off. This delay is for on, and this delay is for what? It's for low. It start again. It's a continuous process. It continues again. So it will be blinking, off on this what? On this condition. So you can also experiment and try it and see. Don't add a delay program and just leave it. So you can also delete this from here to here. From here to here, you can delete it. And you can see the effect. Okay, so this is on this condition. This is when what? When this pin will go what? Will go high. So where is yellow pin? Where is low? Forget about what I write here in the green. I attach a green program here, a low program in this green condition, so that I will not write. And so I discovered that this condition suit my what? my low program on green, so I have to attach it here. So forget about this one first. We'll still come to that. So forget about this one. Do as if you didn't see this condition, this command. Okay, now we are still on yellow. When we yellow turn low, go off on a condition of, I told you this is the only condition when it's going to come on this condition is going to come on this condition is going to what is going to turn low. This condition is going to turn low. So this is the condition is going to turn low. If v2 is less than 3.5, say it's greater here, it's less than 3.5, or v2 is equals to what? 4.5. At 4.5 it has to be low too. It's not its own program, it's a program for red pin, which is red LED. So at that program it has to turn low. So my friend, turn low. That is it. So let's play it and see how it goes. Okay, now I have to download it, upload this program in my Arduino, open my serial monitor, so you can see the voltage 3.5. What is playing here? Oh, yellow is automatically, yellow has started playing on 3.5, voltage of 3.5. What is the 3.5? What is 3.5 here? 3.5, okay, 3.5 is high, supposed to be high. 3.5 and 4.5, this is only on this region, it will be high. So if I go 4.5, it will be high also. Yellow will be high. I'm blocking. I want to hold my resistor. How will I do it? I do it this way. It's better this way. Okay, so now watch the program. I'm increasing 3.6. It's a blinking program, it's blinking. So okay, let me just reduce let me make it 100 so that it will be blinking fast. Okay, let me clear. So my voltage is 3.7, is blinking very fast. Okay, so you can see. Okay, so now let's increase again. Like I said, when we hit 4.5, anything above 4.5 is going to turn low. 3.8, let's go to 4. 4.04. Okay, 4.24, 4.3, 4.4, 4.49, 4.53. You see, it's off. Then the red light comes on. Arduino is what? Precision guided. Okay, so now that is it. So we have entered another mass directory now. We are on another mass directory, which is the red pin. Okay, let's explore the condition of what? Of red pin. Okay, so let's see. Let's go to red. Okay, after the yellow pin, I have yellow. Okay, I have the green pin. Okay, so now the green pin, which is the green LED, which is hooked up on what? On pin 6. I said I wrote it. That is the second program before the red one, which is the last program. So now on green pin, when will green pin turn high? Only because it depends on what you want. Actually, you can see this one has how many conditions? 1, 2, On the low side, 3, 4. It has 4 conditions. 4 conditions with the delay inclusive. So I would say even 5 conditions. So the delay program making it 5. Okay, delay off and on. Okay, delay program making it 5. I have 5 programs here. Okay, 4 conditions, 5 programs written here. So on the green zone, we have what? We have only what? Only one condition here. And that condition for high, that is the only condition for high. And this is the only condition for high. That is the way I choose to write. You can also explore your own and write your own. Okay, so now V2 is what? Is less than, when V2 is less than 3.5 only. So anything 3.5 down, the green light should be, because I have only what? I have only one light. So I didn't mean I have, maybe I have white, I have blue, then I can also share them and put conditions. So because I have only one green, making use of only 3, so I have to just write it only one conditions, put only one condition there. Okay, so it's very, this one is a little bit easier. So it's only when it is 3.5, it is what? It is low. But let's see when it is high, or it is low, on the low side, on the high side. Okay, so on the low side, it cannot be only one condition, because a lot of factors have to be, so that it will not cross to another man's directory. So on the low condition, I came here, I saw that this one suits it's the high. On this place, where is my green light? On this condition of high, my green also doesn't have to come on here. And this condition suits it 3.5. 3.5. And this condition, my green has to be what? Low. So I carried my green digital right, green pin low, I slot it in this condition. In this condition, remember, this is what ends this condition. This closed query, this is open query, this is my condition. This is how my condition begins with open query, and this is the closed query. So that is it. This is how to put it though. Not here, not here, this place. Do it like this, do it like this. Okay, so I discovered that it suits my conditions, so I have to slot it here. I can decide to come and repeat this one here and say on my green after my high, I repeat it again and put it here. It's the same thing. Don't need repeating it. I have to slot in here. Come to this place, I have to slot it here. I have to slot it here. So let's explore this condition. On this condition, when V2 is equals to, when V2 is greater than 3.5 and V2 is greater than 3.5, so it is above 3.5, my green light should be what? Low. It doesn't have to come on. It doesn't have to come on. It doesn't have to come on. And when V2 is also less than 4.5 or equal to 4.5, it doesn't have to what? Come on. So it suits my condition. So that's why it's low on that. So let's explore that and see for the green light. So let's go down. So let's upload again. Okay. Let me open my serial monitor. Okay. I have 4.5. So let's go down. Let's go down below. Start from 0. At 0, we have what? You have what? You have it on. So 0 volts, you have it on. When will it go off? When we hit what? Let's go where we slot in the green light, the green pin. This is the green LED here. This is where we slot it in. So this is on this condition, where on this condition here, this condition binding this program is when this green light will turn low, and the condition starts with what? 3.5. So when I'm hitting 3.5, it's going to go low. So when I'm hitting 3.5, it's going to go low. So let's see. Green light, I have 0. I have what? I have 0.131. I go again. I have 0. What? I have 0. I go again. Then you go again. Okay, 3.2. I never have not hit 3.52. Bam, it's off. And another man's program starts. The yellow light starts. You see it? I've entered another directory. So immediately I'm entering this man's directory. This one goes off. This one picks off. So it's showing me I finished my work here. This one I have handed over to you. It's a relay, like a relay race. It's just like a relay race. Understand? So that is it. So immediately I'm finishing this program, it's handing over. It's a handover button. So the button, this one takes the button. So the race starts with this one. So by the one this one is finishing, it will hand over, you stop, you hand over to this one, and this one starts. Okay, so that is it. And the last program here, which is the red program, which is what? The red LED. The red LED, I'm not going to close my serial monitor, I will just clear it and let's explore it. I will not download again, the program is already there. So this one I started playing already. So let's go and see how we can do the red one. So now on the red pin, so if V2 when this one will turn high, it's only when this one is what, 4.5 and 5.0. so you can see it. If V2 is what, is greater than 4.5, it will turn. So I have 3.61 here, so it will not turn, it will never turn. So when it's greater or equal to, okay, I didn't write equal to, okay, when it's greater than 4.5 and V2 is greater or equal to, it's less than or equal to, sorry, it's less than or equal to, it cannot be greater than 5.0 because that's the highest voltage you have in Arduino. That is the highest voltage, that's 1023 scale, on a scale of 1023 for analog, and the digital side is 255. Okay, so it cannot be more than, so you know what you're writing, it cannot be more than 5.0 volts. Okay, or equal to 5.0 volts, it will come on. So what we have here is 3.5. So let's go and turn it on and increase so that it can come on. So okay, 3.85, 4, 4.5, bam, 4.51 is on. Okay, you are not seeing. The voltage is 4.27, 4.4, 4.44. The yellow is still on the yellow zone. Let's add a little bit. 4.59, the red zone. So this is no go area, this is danger zone, so we have to reverse back. Or in the other case, this is empty tank, you have to fill up your tank. That is it. Or in other case, this is low battery, you have to charge up. Or this is danger, this is stop, you have to stop adding values, or stop throttling, or stop firing. Anything, any scenario you can fix it off. It's you that knows the program that you write to suit in your scenario. Okay, so that is it. And on the low side, you just know that the low side should be the reverse of all these things. In the low side, anything below 4.5, just like you say, it's above 4.5 and it's equal to 5. Anything below 4.5, this guy has to be what? 0. Anything below 4.5. So let's do it again. If V2 is less than 4.5 or V2 is greater than 5.0, which you know it can never be greater than 5.0. So this one is irrelevant here. From here, it's irrelevant. I just want to add it. It's irrelevant, not doing anything. It can never be greater than 5.0. That's the maximum you have here. So if you have other voltage, you can say this condition can apply, but you don't have this. So this alone can go. This alone can go. If V2 is what? Is less than 4.5, my man should turn what? Go off. So that is it. So let's do it and see. Let's clear and start again. I'm holding the variable resistor so that it will not pull off because it's not all that strong here. Okay, so now let's go. Okay, you see it's 4.41, 4.3, and another man program I've started. If I go down to 0, this one will start. If I come up maybe to, I have 2.5, this one is still on. Okay, so that is it. So that is the end of the drill. That is the end of the drill. Okay. Okay. I'll go high to the last one. Red. Okay. To the downside you have green. To the high side you have red. To the middle side of it you have yellow. What is the voltage? Okay, it's not up to 3.5. Okay, you have yellow. Okay, so that is it. Okay, so that is the end of the drill. It's a long words. That's a long lecture and it's a long tutorial. On this tutorial 18, we have a different scenarios. We apply the 3 LEDs and we can be able to see the different if conditions, if statements, and we use all the greater than, less than, equal, and all of that. So we use all the conditions that we have in Arduino programming, so for you to be able to see and understand what we are doing. Now on this, only this alone, this type of a comparator scenario, we are going to use it to do a lot of things. At this level, somebody can be able to apply this program in real life application and get results. Level controllers and battery charging systems and the other controls, electrical controls, at this level, start up the mixer, at this level of water level, start up the pump, something like that. So you can create amazing designs. You can produce a design schematics and hook it up with your solid state relay or your relay shields, and you fire up your contactors and your motor fires up, or your compressors, and that is it. You can be able to do a lot of you can be able to design something with this at this level. At this level, you can be able to hook up something to the Arduino and you fire up and find that is controlling it. Maybe I will do one experiment and I'll do one project with this. At this level, I'll have to do something, hook up something. I'll come up with something. I'll hook up to this program. This program alone, I'll hook up something to it. You see where it's controlled. So you use your light emitting diode. Use a light emitting diode to stimulate. This is simulation. What we are doing here is simulation. We are just simulating. In place of this, you can put your op amp and you fire down. In place of this, you can put your op amp. If you don't want to use op amp directly, you can hook up your sensor, your LM35, and that is LM35 should be a temperature sensor, and you can use it to simulate different temperature levels at which it will fire up, and that is it. Different temperature levels, it will fire up the Arduino, and the Arduino will fire up the relay, and the relay will fire up maybe the compressor or the heater or whatever thing you hooked up in the system, the load. Okay, so that is it. So we use the light emitting diode scenario to simulate. This is simulation. We are simulating, and whatever you see as it's playing here, that is how it's going to play in the real life. And at the end of it, you have the red. At the middle of it, you have the yellow. In the middle of it, you have the yellow. Okay, you have the yellow blinking. So that is it. Okay, so once again, I'm your one and only Mr. Great here in Mr. Great Tech Review Studio, bringing technological updates and also bringing technology to your doorstep. If this video makes sense to you, like and share so that others will benefit, and do yourself a favor by going to my YouTube channel to subscribe. You like, you subscribe. That is where I have an opportunity to post long-lasting videos. So go there, subscribe, like, and you share. God bless you. See you next time on our tutorial number 19. And you leave that one for me to decide what I'm going to come up with. God bless you.